Normality test is a statistical procedure used to determine if a sample or data set comes from a population that follows a normal distribution. Normal distribution, also known as Gaussian distribution, it is symmetrical bell-shaped distribution. What we mean by bell shape is like this. Shape like this, like a bell shape distribution. The normal distribution is fundamental to many statistical and data analysis. What this means that for you to do a lot of this statistical analysis, you have to test for normal distribution. Statistical tests like t-test, ANOVA, regression. For you to carry out those statistical analysis, you have to carry out a normality test to test the normality test. For this purpose of doing normality test, the first purpose of doing normality test is to verify whether data can be assumed to be normally distributed. So to check if the data is normally distributed, most of the most of the technical statistical techniques we mentioned above, like the t-test, ANOVA, the regression, the assumption is that the data have to be normally distributed. So we do the normality test to test if our data is normally distributed. Another way is to ensure that the validity of parametric statistical tests can rely on the assumption. Like the statistical test we mentioned above, the regression, ANOVA, and t-test, they are all parametric statistical tests. We have non-parametric tests. So the assumption of parametric tests is that your data have to be normally distributed. Common normality test. These are the tests. These are the types of normality test. We have graphical method. These are the method used in testing for normality test. We have graphical method. Graphical method, the use of histogram. We use histogram and QQ plot to test for normality test. We have test method. Test method like QNES, ketosis, Shapiro-Wilk test, and Kolmogorov-Smirnov test. These are the tests we are going to do now. These are the tests we are going to carry out using SPSS. So in our data, we are going to test for normality. How to carry out the normality test. So these are the method we can use in carry out the normality test. We have histogram, we have graphical method, which is histogram and QQ normal plot, which is quantile plot. The other tests are QNES, ketosis, Shapiro-Wilk test, and Kolmogorov test. So what we'll do is that I've inputted data in SPSS. So what we'll do is that you go to analyze, go to descriptive statistics, and go to explore. So this is the name of our data. Move this sales data into dependent list. So if you look at this display, you will see you have both here. You have statistics, you have plots. If you want your output to come out in both plot and statistics, you pick this plot. The statistics there is the skewness, ketosis, Kolmogorov, etc. There is statistics. The plot for testing the normality I had the histogram and the QQ plot. So I won the two, so I'll pick the both. So let's check the statistics. We want. Yeah, we didn't need this. Go to plot. So and check the stem and leaf. You can use that one too, but I'll go for histogram. Check histogram. You can check this to normality test, normality plot with test. Continue. And then click OK. These are your outputs. This is just all. Everything is here. You can see all of our results here. So I have copied everything into Microsoft Word for explanation. Let's go. Don't forget to subscribe to my YouTube channel and turn on the notification. Please share to your friends. For more data analysis, comment, subscribe, and turn on the notification. Thank you. Follow me to Microsoft Word. Let me explain the results. If you look at the histogram, this histogram, if you look at it, the output look like a normal distribution, like a bell shape. Look at it. It's a bell shape distribution. It's what called bell shape distribution. Bell shape histogram. You know that your data may be normally distributed. This is our normal QQ plot, quantile plot. If you look at it, if the point in the QQ plot closely follow the reference line, the data can be assumed to be normally distributed. Look at it. Look at the point where it follows it directly to up. So our data can be assumed to be normally distributed. So this is our other test. We have Kolmogorov, Simonov, and Shapiro-Wilk test here. So our assumption, our hypothesis here is that each node says the sales data is normally distributed, while the each one says the sales data is not normally distributed. If you look at the p-value here, the p-value for Kolmogorov is 0.20, that is 0.20, which is not statistically significant. So we cannot reject the null hypothesis. This is the null hypothesis. So we can't reject this null hypothesis. So we conclude that our sales data is normally distributed. Look at the Shapiro-Wilk too. Shapiro-Wilk. The p-value here is greater than 0.05. P-value here is 0.93. So we cannot reject the null hypothesis. We conclude that our sales data is normally distributed. I hope this class helped you to learn a bit of data analysis. Please subscribe to our YouTube channel, turn on the notification for more data analysis coming your way. Thank you.